Mr. Corsi here. Following on for our previous videos, if you stop this video now and try these examples, and then we'll look at the solutions. Okay, question 1, root 3 plus I cubed. When you see root 3's and 1i's, you think of this equilateral triangle of side 2 chopped in half, and you get the 1 root 3 2 right angled triangle with angles of pi upon 6 and pi upon 3. In this case, if we orientate it in the correct way, we can see there that we've got root 3 1i, so that point represents the complex number root 3 plus I. And so we get the modulus of 2 and the argument of pi upon 6. So let's tackle this question. We take the Cartesian form, root 3 plus I, and change it to the polar form. So 2 cos pi upon 6 plus I sin pi upon 6. And we're raising root 3 plus I, that Cartesian form, to the power 3. So the whole of that gets raised to the power 3, 2 cubed is 8, and that leaves us cos pi upon 6 plus I sin pi upon 6 to the power 3. And that's where de Moivre's theorem comes in. So we have 8 times. Now de Moivre's theorem tells us to multiply the argument by 3. So 3 lots of pi upon 6 is cos pi upon 2 plus I sin pi upon 2. So we're in a position to evaluate this now. Cosine of pi upon 2, quick look at the cosine graph. Starts at 1, goes down to 0 for the angle pi upon 2. And we'll have a look at the sine graph. Remember, it starts out at 0 and goes up to 1 for the angle pi upon 2. So that second bracket has a value of 1 times I. So we've got 8 times I. That's 8i. So let's now move on and we'll have a look at question 2. So again, we've got 1's and root 3's. That would imply the equilateral triangle of side 2 chopped in half. And the orientation this time is slightly different from the last example. And there we go. So you can see 1 along and root 3 down. So this point down here represents complex number 1 minus root 3i. And again, as in the last example, it's got a modulus of 2 and an argument. This time it's not pi upon 3, it's negative pi upon 3. So let's take the Cartesian form, 1 minus root 3i, and we convert it to the polar form. So modulus of 2, argument pi upon negative pi upon 3. So cos negative pi upon 3 plus I sin negative pi upon 3. And we're raising it this time to the power 4. So the modulus will be raised to the power 4, that's 2 to the power 4, that's 16. And we multiply the angle by 4, that will be negative 4 lots of pi upon 3, plus I sin negative 4 lots of pi upon 3. So, to work out the value of cosine negative 4 pi upon 3, we can add 2 pi to that angle. That's 6 lots of pi upon 3 to the negative 4 pi upon 3, give us 2 pi upon 3. So that's adding 2 pi to both angles. And then we consider the angle of 2 pi upon 3. Let's look at the quadrant diagram. 2 pi upon 3 is a second quadrant angle. And we'll basically be dealing with pi upon 3 in the second quadrant. And we know in the second quadrant that the sine's positive and the cosine's negative. So cos 2 pi upon 3 will be the same as the negative of cos pi upon 3. And sine 2 pi upon 3 the same as positive sine pi upon 3. And for the values of cos pi upon 3, sine pi upon 3, we use the familiar diagram now. Cosine would be adjacent over hypotenuse, that's 1 over 2. So negative 1 upon 2 plus I times now sine of pi upon 3 opposite over hypotenuse, that's root 3 upon 2. And just a case of multiplying out, 16 times negative a half is negative 8, and 8 root 3i. So let's move on to question 3. So 1 plus I, we're raising that to the power 8. So the diagram this time is half a square of side 1, diagonals root 2, angle pi upon 4. And the orientation, well, we just leave it as it is. And that allows us to get 1 along the real axis and 1 up the imaginary axis. That point up at the top there represents 1 plus I. So modulus root 2 argument pi upon 4. So Cartesian version 1 plus I, polar version root 2 cos pi upon 4 plus I sine pi upon 4. And that's what we're raising to the power 8. Now, root 2 to the power 8, the root 2 times root 2 is 2, so it'll be 2 to the power 4, which gives us 16. And then de Moivre's theorem kicks in. This all to the power 8, we multiply the argument by 8. So we've got 8 lots of pi upon 4, which would be 2 pi. And all that's left is therefore to evaluate cos 2 pi. Quick look at the cosine graph. 2 pi would be 1. And look at the sine graph. 2 pi would be 0. So that right-hand bracket has value 1, so it's 16 times 1, which just gives us 16. So, moving on to example 4, here we have negative 1 plus I. Again, it's the half a square diagram. This time the orientation is slightly different. We'd have to flip that over. It's allowing us to go 1 to the left, negative 1, and 1 up. There's the point that represents negative 1 plus I. So in this case, the amplitude is still root 2, modulus still root 2, but the argument is 3 lots of pi upon 4. It's a second quadrant angle there. So negative 1 plus I, it's the Cartesian form. Polar form then, modulus is root 2, argument's pi upon 4, so it's 3 pi upon 4, sorry, because 3 pi upon 4 plus I sine 3 pi upon 4. And that's what we're raising to the negative 10 this time. Now, root 2 to the 10, that would be, well, let's figure that out. Root 2 times root 2, a couple of these give you 2. That means there's 5 lots of that. 5 pairs making up the 10. So it's 2 to the power 5, and that's 32. And the negative means it's 1 over 32. And to determine the angle, well, that's slightly more complicated. Let's take 3 pi upon 4, and we know we're multiplying it by negative 10, so that's negative 30 over 4, which gives us negative 15 pi over 2. We'll deal with that in a minute. So there's plus I sine negative 15 pi over 2. Now, we can add multiples of 2 pi to negative 15 pi over 2. And 2 pi is 4 pi over 2, 4 lots of pi over 2. So anything like 4 pi over 2, 8 lots of pi over 2, 12 lots of pi over 2, another 2 pi would give us 16 pi over 2. That's a useful one. If we add 16 lots of pi over 2 to minus 15 lots of pi over 2, we get 1 lot of pi over 2. So it's cos pi upon 2 plus I sine pi upon 2. There we go. So cosine of pi upon 2, there's the cosine graph, it's 0. And similarly, sine pi over 2 goes from 0 up to 1, so it's 1 for sine pi upon 2. So the right-hand bracket has value 1i. So it's just 1 over 32 times I. And that's our final evaluation. So finally, question 5. Here we have root 3's and 1's again, so that we're back to the equilateral triangle of side 2. That diagram will be the one that we deal with. And the orientation this time will be slightly different. Let's think about that. We're going root 3 to the left and 1 up. So there's the root 3 to the left and 1 up. So this point here represents negative root 3 plus 1i. And modulus is 2. That angle in there is pi upon 6. So the actual argument of that complex number, 5 pi upon 6, second quadrant angle. So we know the rooting now. We've got the Cartesian form, negative root 3 plus I, and the polar form, 2 cos 5 pi upon 6 plus I sine 5 pi upon 6. And this time we're raising complex number to the power negative 12. Now that's a hefty calculation for this part, 2 to the power 12. So take my word for it, it's 4096, with a negative means it's 1 over 4096. And then for the angle, we have to take 5 pi upon 6, multiply it by negative 12. And let's look at that. 5 pi upon 6 times negative 12. Well, the 6 goes in 12 twice. It's negative 10 pi when that's worked out. Plus I sine negative 10 pi. So modulus 1 over 4096. Now, adding multiples of 2 pi, well, 10 pi is a multiple of 2 pi. So if we add 10 pi to that, values remain unchanged, we'd get a 0. So cos 0 plus I sine 0, it's adding 10 pi, a multiple of 2 pi. So cosine of 0, that's 1. Sine of 0, that's 0. So right-hand bracket's the value 1. So our final value is 1 over 4096. So that's Mr. Corsi signing out, and hope you enjoyed the video.